Hey students, this is lesson 10-2, part 1, simplifying radicals. We're going to learn how to simplify radical expressions, what it means to be a simplified radical expression. Take close attention to this vocabulary because there's some important words here. These first couple problems didn't print correctly, so I think this is actually supposed to be the square root of 36, which is 6. This is supposed to be the square root of 100 ninths, which is 10 thirds. And this is supposed to be the square root of 144, which is 12. And 6 thirteenths. Okay, so some vocab here. The number underneath the radical sign is called the radicand, and the whole thing altogether is called radical. All right? So, true or false, the expression square root of the quantity w plus 2 is a radical expression. That's true. The radical expression square root of 121 is in simplified form. False. Think about that, what it should be. The radical expression 5 times square root of 7 is in simplified form. That's true. And I didn't review these, but I hope you check this out. To be simplified, the radicand has no perfect squares factors other than 1, and that's the reason this one's false, because this 121 is a perfect square, so we could just write that as 11. The radicand contains no fractions, so something like this would not be simplified. I'll just put that not simplified. And radicals appear in the no radicals appear in the denominator of the fraction. So another example of not simplified would be something like this: 3 divided by the square root of 2. That's not simplified. So we're going to learn how to simplify those in this lesson. The radicand in the radical expression 5 times the square root of 7 is 5. That's false. The radicand is the number underneath the radical symbol, so that would be 7. The radical expression 5 divided by the square root of 3 is in simplified form. False, because there's a radical in the denominator. All right. So one important property you have to know is the multiplication property of square roots in order to simplify radicals. What we're saying here is you can break up a radicand by its factors and it'll still be true. And that also goes for division. You can break up quotients that way also, and that'll be coming up here in a second. But basically what we're saying is if we have the square root of, say, let's do square root of 100, so you can see this is true, that is equal to the square root of 4 times the square root of 25. And you can see that's true because the square root of 100 equals 10, square root of 4 is 2, square root of 25 is 5, and obviously 2 times 5 is 10. So you can see that works. And here's an example of how it doesn't work. You cannot break up square roots by sums. So, and to prove that, again, I'll use the square root of 100. That's not equal to the square root of 36 plus the square root of 64, even though 36 plus 64 equals 100. And just to prove it, the square root of 36 is 6, square root of 64 is 8. And so 6 plus 8 would have to equal 10 for that to be true, and obviously that's not true. So the square root of 100 is not equal to square root of 36 plus the square root of 64. The square root of 100 is equal to the square root of 4 times the square root of 25. So cross out the equation below. That is not true. 49 times 2 is 98. That one's good. 100 times 2 is 200. That one's good. 7 times 4 is actually the square root of 16. And that definitely is not equal to 28. So, all right, so we're going to use these ideas to simplify. So think about this. Why is the square root of 125 not simplified? The reason it's not simplified is because it has a factor that's a perfect square. And that factor that's a perfect square is 25. So let's use the multiplication property of square roots to rewrite it using that perfect square factor of 25. And 25 times 5 is 125. Then we're going to simplify the parts that we can. The square root of 25 is just 5. And so the answer is, and we don't, normally you don't put a symbol like times in there, you just write 5 times the square root of 5 like that. All right, I'll let you try that here. Actually, maybe, I'll go through this one with you. Some variables can also be perfect square factors, and it comes from this. The square root of x squared is equal to x. All right? The square root of x to the fourth is equal to x squared, because, and you can just check it, the reason it's true is because x times x is equal to x squared, the radicand. And x squared times x squared is equal to x fourth, the radicand. The square root of x to the sixth is equal to x to the third. The square root of x to the 20th is equal to x to the 10th. So even powers of variables are perfect squares. Now when you get an odd power, there is a perfect square in there, and that's what we're going to do here. So we have square root of 243x to the fifth. Well, remember, we can use the multiplication property of square roots, and we can break this up into its factors. We want perfect square factors. If you divide 243 by 3, you get 81, and 81 is a perfect square. So we're going to break this up this way. 81 times 3 is 243. And, oops, I did that wrong. That's x to the fifth. And x to the fifth we can write as the product of a perfect square, x to the fourth times x. And remember, x is just x to the first, so if you think about that, 4 plus 1 equals 5. Now we're going to simplify as much of this as we can. Square root of 81 is 9. Square root of 3, we can't simplify that. Square root of x to the fourth is x to the second. And the square root of x, we can't simplify that anymore. Now everything that is not a radical anymore, we're going to put that in front. So that's 9x squared. And then the things that couldn't be simplified, the 3 and the x, we're going to leave those underneath the radical sign. And so we get b. All right? I'll go through this one with you. What is a simplified form of negative m times the square root of 80m to the 9th? Circle the factor tree that shows the greatest perfect square factor. So obviously all of these are ways to factor 80. And we're looking for perfect square factors. 4 is a perfect square factor, but if you can find a bigger one, use it, because this 20 still has a perfect square factor in it, so we'd have to do a little more work there. So the one that we want is this one right here. All right, and then we're going to use those to rewrite this expression. And notice we're doing 16 times 5 right here. And we're also breaking up the m to the 9th into m to the 8th times m, because m to the 8th is a perfect square. So we now have negative m times the square root of 16m to the 8th, and that's a perfect square, times square root of 5m. And 4m to the 4th times 4m to the 4th equals 16m to the 8th. So the square root of 16m to the 8th is 4m to the 4th, times the square root of 5m. And we can simplify this and this. That's m to the 1st, and m to the 4th makes m to the 5th. And that's what it looks like when it's simplified. All right, more examples. Why are the following radical expressions not in the simplest radical form? Actually, I'll do this tomorrow with you. What is the simplified form of this? Okay, think about why it's not simplified right there. That number 12 has a perfect square factor, and so does the second. So we want to break that up a little bit here. 4 is the perfect square factor of 12, so we're going to put square root of 4 there, square root of 3, square root of z squared. So that is the same as that part right there, times 5. And square root of 4 is the perfect square factor, but z is not. So we'll separate those. And then just simplify everything you can. Square root of 4 is 2. Square root of 3 you can't simplify. Square root of z squared is z. And then square root of 4 is 2. Square root of z we can't simplify. Everything that's not under a radical sign, we'll combine those. So 3 times 2 is 6, times 5 is 30, times 2 is 60. And then, we have a z there, and then these parts are still underneath the radical, and they can't be simplified anymore, so we're going to leave them underneath the radical. So that's what we get. All right. I'll let you try that. You can check back with your answer. You might have noticed that they're showing you another way you can do this. You can combine and multiply them together first. I chose to leave them separate in my last example, just to show you how I could have done that one different up here if we wanted to. We could go ahead and multiply this 12z squared times 4z. I just think that would complicate it. So then we would get 15 times the square root of 48z to the third. Now I would have to break that up again. And I would use square root of 16 as a perfect square. Square root of 16 times 3 is 48. And I would have to take the z squared out of there. And then after simplifying that, I would end up with 15 times 4 times square root of 3 times z times square root of z, and I would still get that. So you can choose whichever way you think is easier. Okay, writing a radical expression. Both A traveled 4 times. I think that's about where I ended. So we're going to end right there, and I'll see you tomorrow.